Welcome to Areas of Regular Polygons. I'm Mr. Pi, the math guy, and we're going to continue our work in our unit on areas by looking at the area of regular polygons. Now, there's one formula for the area of regular polygons, but it's different for every one, and I'm going to show you how that is in examples coming up. Let's get this geometry party started. Here we have some about any regular polygon. The center of a regular polygon is the center of the circumscribed circle. We can see that right here. The center of the polygon and the center of the circle happen to be the same thing. The radius is the distance from the center to the vertex. So here we have the radius. It's the distance from the center to the vertex. It's also the radius of the circle. Now here's this funny little word here in the last sentence. The apothem is the perpendicular distance from the center to the side, and that's right here in red. That's this distance right here, and that's going to be important when it comes to the formula. This distance from the center to the side of the polygon, the regular polygon, is the apothem. Now, you may hear some other people call it the apothem, the apothem. It's just like potato, potato. I want to thank my good friend, Mr. Ion, for letting me in on that little secret that, it's either way. He's heard it either way, so thank you very much, sir. Example 1t, we are given a portion of a regular hexagon, and it has an apothem and a radii drawn. Find the measure of each numbered angle. Now, the reason it's going to be important for you to be able to figure out these angles is it's going to help us find the length of the apothem sometimes with one of our special triangles. 30, 60, 90, or 45, 45, 90 triangles. So let's take a look at how to find the angles here. It's good to note that we have a portion of a regular hexagon. This is half of a regular hexagon. We can see here that the radii, the red lines, the red dashed lines, that's going to split the entire thing up into 6 equilateral triangles. And in this case, the black lines and this radii form one of those equilateral triangles. So we can figure out that the measure of angle 1 is equal to 60 degrees because that's one of the angles of an equilateral triangle. Another way you could think about that is if you travel around, say starting here, and go around, you've gone around in a circle, which is 360 degrees. And each one of these angles, 1, and then this angle here, and then this angle here, are going to be equal because it's a regular polygon. So we could have gotten that by taking 360 degrees and dividing that by the 6 angles formed by the triangles inside of this regular polygon. The measure of angle 2 is going to be equal to 30 degrees. And the reason we know that's 30 degrees is because these two radii and this part of the polygon, this hexagon, form an equilateral triangle. This is a perpendicular distance from the vertex to the opposite side of a triangle. And when it's perpendicular and it's an equilateral or an isosceles triangle, we know that this angle is split in half. So we can calculate the measure of angle 2 by taking 60 degrees, the measure of the angle between the radii, and dividing it by 2. And finally, the measure of angle 3 we find by using the triangle angle sum theorem. Now that we know the measure of angle 2 and we know that this angle is 90 degrees, we take 180, and from that we subtract the sum of the measure of angle 2, which is 30 degrees, plus the 90 degree angle. And if you plug that into your calculator or you do some basic math, that ends up giving us 180 degrees take away 120 degrees, and that the measure of angle 3 is 60 degrees. So that's how we find the different measures of those special angles in a regular polygon formed by the radii and the apothem. Here we have another theorem, the area of a regular polygon. The area of a regular polygon is half the product of the apothem and the perimeter. So area is equal to 1/2 times the apothem times the perimeter. A lot of times we're going to have to calculate the perimeter. And the perimeter is a product. It's the length of one side times the length of how many sides there are. So often we can either do that calculation before we substitute into the problem, or we can do it as we substitute into the problem. We're going to see that coming up in example 2t. In example 2t, we're asked to find the area of a regular polygon with 20 12-inch sides and a 37.9-inch apothem. To start any kind of problem where I'm required to find the area, I like to write down the formula I'll be working with. The area of a regular polygon is equal to 1/2 times the length of the apothem times the perimeter of the polygon. To solve this problem, we have to calculate the perimeter of the polygon. So the perimeter of this polygon is going to be equal to the number of sides times the length for one side. So the perimeter in this case is going to be equal to 20 times 12 inches. We're given that information. It's written out. 20 12-inch sides. Well, that perimeter then is going to be 240 inches. 20 times 12 is 240. So we substitute into the area formula 1/2 times the length of the apothem, which is 37.9, that'd be inches, times the perimeter, which is 240 inches. Now, you could, instead of putting 240 in here, you could put in 20 times 12 and just plug this all into your calculator. When you multiply 1/2 times 37.9 times 240, that ends up giving us a value of 4,548, and the units on that would be inches squared, square inches. The key thing that you need to take away from this is you have to find the perimeter of the regular polygon, and that's simply a matter of multiplying the number of sides by the length of each side. And in this case, in this example 2t, we were given the length of the apothem. And the next example, we're going to have to calculate the length of the apothem. Example 3t. A library is in the shape of a regular octagon. Each side is 18 feet. The radius of the octagon is 23.5 feet. Find the area of the library to the nearest 10 square feet. So this boils down to, after we read the problem, if you need to reread it, you can. What it boils down to is we need to find the area of the library. It's a regular octagon, meaning it's a regular polygon. We're told that each side is 18 feet. We're told that the radius, the distance from the center to the vertex, or to a vertex, is, we're told that that distance is 23.5 feet. What we need to calculate is the area, and to calculate that area, we have to find the distance or the length of the apothem, which is the distance from the center to one of the sides that is perpendicular. Key thing to understand is if the sides are 18 feet, then the distance from the point where the apothem intersects the side to the vertex is 1/2 of that, and that's 9. So to calculate this apothem, this is an A and this is a 9. To calculate this apothem, we have to use the Pythagorean theorem and solve for one of the legs. So we first have to find the apothem. And the distance of the apothem is going to be given by the Pythagorean theorem, where we have a squared plus b squared is equal to c squared. We substitute in what we know. We're going to solve for a squared. Add into that the distance of the one leg squared, which would be 9 squared, and that has to be equal to the hypotenuse squared, which is 23.5 squared. Well, when I go through that calculation, and we can manipulate that a little bit. First, we're going to subtract 9 squared from each side, so that would give us a squared is equal to 23.5 squared minus 9 squared. And then we'll take the square root of each side, so we end up with a is equal to the square root, and I switched, yeah, that's correct, and I can write this down as 23.5 squared minus 9 squared. And I can plug that in them. Ends up being approximately 21.7 feet. So A is 21.7. So now I can use the formula for the area, which says area is equal to 1/2 the length of the apothem times the perimeter. Now I'm going to do the perimeter a little bit differently here. We have 1/2 the length of the apothem, which is 21.7 feet, times the perimeter. Now I'm going to write the perimeter as an expression. Each side is 18 inches, and there are 8 sides. Now how do I know that there are 8 sides? It tells me it's an octagon, and an octagon is an 8-sided polygon. Now I can run this into my calculator. 0.5 times 21.7 times 18 times 8. And when I do that, it comes out to give me this number approximately, 1,562.4, and that would be square feet. But this isn't the correct answer because it wants us to round it to the nearest 10 square feet. So I want to round it here in the tens place. So when I round that, the 2 tells me to keep the 6 a 6 and make the ones place a 0. So that'd be approximately 1,560 square feet. And that would be the area of that library. Key thing is we had to use the Pythagorean theorem to find the length of the apothem. The length of the apothem was not given to us.